Let's talk display stream compression. If you're in the market for a high-end monitor and you're planning to pair it with an NVIDIA GPU, you're going to run into limitations with NVIDIA features and possibly observe issues. I'll get into those in a second, but first let's cover off what display stream compression or DSC is and then look at an example case. So DSC is used as a way to get around the bandwidth limits of both DisplayPort 1.4 and HDMI 2.1, both of which use DSC 1.2. DSC is an algorithm to compress video signals, allowing a more efficient transfer of the signal data, effectively allowing higher resolutions and higher frame rates than would have otherwise been possible without the use of DSC. It's claimed as being visually lossless, whereby humans shouldn't be able to notice that DSC is in use. I will put a link below to the Wikipedia page for it, just in case you want to see the algorithm for yourself. So let's have a look at a quick example now. Let's say you have a brand new 1440p screen running at 360 Hz or 480 Hz. Well, neither DisplayPort 1.4 or HDMI 2.1 support 1440p at that high refresh rate. So we know straight away that display stream compression has to be in use to achieve those target frame rates. That's at 8-bit color, which is SDR content. If you're looking at HDR, which runs at 10-bit color, well, then your bandwidth requirements are going to go up even higher. So the takeaway is, if you ever see a screen advertised as 1440p, 360, 480 Hz, or maybe even 4K at 240 Hz, you straight away know that they must be using display stream compression. Alright, so what problems can we have from using our NVIDIA graphics card with a display that has DSC enabled? First problem you can have is multi-monitor support. Out of the box, an RTX 4090 will support 4 external monitors. If one of those screens has DSC enabled, then you are down to 3 external monitors in total. The reason for this is a DSC enabled screen will surpass the bandwidth limit that an NVIDIA graphics card has for an output head. It will have to then fall over and use a second output head. So another way to think of this is a DSC screen technically counts as 2 monitors for the graphics card. Following that same logic, if we know that the total number is 4 and we are using 2 monitors, both of which have DSC, you cannot then connect a third monitor into your graphics card and expect it to give you an output. The second problem you're going to have is with NVIDIA's Deep Learning Dynamic Super Resolution, or DLDSR, or even just normal DSR, or image scaling. If you're into using any of those, you cannot use them if your monitor is in DSC mode. That is very common technology to be used at 1080p and 1440p, where you want to upscale your image and then output at the native resolution, effectively giving you a better anti-aliasing quality. That is gone once DSC is enabled. Third problem you're going to have is with G-Sync. If you have G-Sync enabled and your screen has DSC enabled, then if it wakes up from sleep, sometimes it just won't wake up and you'll get a black screen. Other times, if you're in a game and the game is set to full screen, and let's say you go and click on a second monitor, or if you try to alt-tab your full screen game, your DSC monitor will just show a black screen for a few seconds before it springs to life. Alright, the fourth problem you're going to have is, and this is a minor one, but still annoying for people like me who do use this tool, is CRU. It's Custom Resolution Utility. If you want to go in and make a custom resolution or tweak specific settings of your monitor, as soon as the NVIDIA driver realizes that your screen has DSC enabled, it will ignore every single change you try to make using CRU. It's really annoying. What is the takeaway here? Well, if you're in the market for a new screen and either of these 4 issues sound like they're going to be a deal breaker for you, make sure to buy one that lets you disable display stream compression. If it's not urgent, maybe even just wait until next year before you buy, because new graphics cards, new monitors, hopefully DisplayPort 2.0 becomes standardized, which has over twice the bandwidth of DisplayPort 1.4. So yeah, look, until next time, thanks for watching, as always. See ya.